Hi everyone, in this video we will be focusing on calculating the p-values of different elements from a given solution. Okay, but first let's discuss what is p-value and why is it used especially in measuring concentration for elements. Okay, so let's discuss first the fundamentals. Okay, fundamentals of p-value. Okay, this will be just a brief introduction. I won't dive through deep through this discussion because this video will be more focused on solving. Okay, fundamentals of p-value. So basically, when you say p of x, so x can be any element, so it can be hydrogen, Cl, sodium, anything, okay? Depending what element you are focused on or you want to measure. So Px or the p-value of x simply implies the negative logarithm base 10 of x, okay? This is simply a mathematical operator, okay? But why is it used? So accordingly, it is used because oftentimes, right, we obtain extremely small or extremely large concentration. By using this mathematical operator, we can transform these extremely large numbers or small numbers in several orders of magnitude, thus having a more manageable scale. So simply, this converts large or small concentration values into a more manageable scale. Okay. For example, okay, let's say that you were measuring, okay, example, you were measuring the concentration of um, the acidity or H plus, the acidity of a solution, okay, and you have found in molarity concentration that it was 6 times 10 to the negative 5 molar. Now, if you write it out in non-scientific notation, that would be 0.12345. So that would be 0.00006 molar. Okay, so this is an extremely small concentration and sometimes not really manageable scale to look at, right? So by using the mathematical operator negative logarithm, we can turn this into a more manageable scale. Okay, so let's turn this H plus to a more manageable scale. So this is simply called pH. Okay, and to obtain that value, let's simply negative log base 10. So x here would be 6 times 10 to the negative 5. Okay, you can calculate this using your calculator. Just simply input negative log 6 times 10 to the negative 5, and that is simply 4.22. Okay, this is unitless. Okay, note this is unitless. Okay. So that is basically the foundation or fundamentals of the p-value. Okay, so this is why we use p-value. Okay, now let's solve uh, the given problem. Okay, calculate the p-value for each ion in a solution that is 2 times 10 to the negative 3 molar in NaCl and 5.4 times 10 to the negative 4 molar in HCl. Okay, So let's understand first the question. We must calculate the p-value each ion. Okay, so each ion, meaning we need to look at this individual ions. Okay, so we have NaCl and we have HCl. Let's look their ions. So NaCl is simply Na plus and Cl minus. HCl is H plus and Cl minus. Okay, so we need to calculate the p-value of these ions given their molar concentration. For sodium, that would be P and A, right? So P and A, so negative log, what is the concentration? Where can we find the concentration of sodium? In the sodium chloride, right? Or NaCl. So let's find the p-value of Na from this 2 times 10 to the negative 3 molar because that is NaCl. So negative log 2 times 10 to the negative 3 molar. So simply input to the calculator and that is 2.70. So we got the sodium p-value. Now let's jump to H plus. Let's calculate the last one for Cl minus because this will be a more difficult way of solving because as you can see here, they have a common ion. NaCl has a Cl minus as well as the HCl has a Cl minus ion. Okay, let's start with the easier one. Okay, so for H plus, that is pH. Okay, so where can we find the concentration of H plus in HCl? Because that's the one containing H with the concentration 5.4 times 10 to the negative 4. So simply negative log 5.4 times 10 to the negative 4, which is 3.27. Okay, remember that this is unitless. Okay, so we got the pH now and the pNa. So the last one would be PCl. Okay, so in this case, the Cl minus or the chloride ion both exist from NaCl and HCl. So we can calculate their concentration by summing both of this molar concentration. Okay, let's see here. So I'm talking about this. So negative log, let's add both the concentration from NaCl and HCl. So that's 2.00 times 10 to the negative 3 plus 5.4 times 10 to the negative 4. Okay, why did we do this? Because chloride ion exists in both NaCl and HCl, okay? So we must calculate the PCl value from both of their concentration. So let's add this first. That is 2.54. So that would be 2.54 times 10 to the negative 3. And negative log of that is 2.59 or 2.60. Okay, so that's it. The P and A is 2.70, pH is 3.27, and the PCl is 2.60. So just remember here, if they have a common ion, simply add them up before you do the negative log of that value. Okay, so for the next problem, you can try this out or you can follow along. So, calculate the p-values for all ions present in a solution. That is 1.80 times 10 to the negative 3 molar in sodium nitrate or NaNO₃ and 4.5 times 10 to the negative 4 in HNO₃. First off, we can see here they also have a common ion, which is we were tasked to find the p-values from NaNO₃ and HNO₃. Okay, let's see their ions. So NaNO₃ is Na plus, and they also have NO3 minus. For HNO₃, it has H plus and NO3 minus. Okay, so they both have NO3 minus, right? So let's start with PNA. So for PNA, we can find sodium from the sodium nitrate with the concentration 1.8 times 10 to the negative 3. So this is simply negative log 1.8 times 10 to the negative 3, which is 2.74. And next would be P. Okay, let's jump to pH. Okay, negative log. So H can be found in HNO₃ with a concentration 4.5 times 10 to the negative 4. So this is in molar. 4.5 times 10 to the negative 4. That is 3.35. Okay, so we have the P and A and pH. Now let's solve for the P and O3. Okay, so for the P and O3, it exists both from HNO3 and NaNO₃. So let's add it up. So 1.8 times 10 to the negative 3 plus 4.5 times 10 to the negative 4. Okay, so that would be, so adding it up, that would be 2.25 times 10 to the negative 3. And then the PNO3 is 2.64. Okay, so that's basically like the last problem, right? So we have the PNA, pH, and PNO3. Next question. Calculate the p-values for all ions present in a solution. That is 4 times 10 to the negative 3 molar in calcium chloride, CaCl₂, and 6 times 10 to the negative 5 molar in sulfuric acid or H2SO4, assuming complete dissociation. This problem is difficult, but this is solvable, okay? So let's start first by determining the ions in the solution. Okay, we have CaCl₂ that has Ca2 plus ion and Cl minus ion, okay? But note here, we have two chloride in one CaCl₂, okay? Okay, just note this first. Next, we have H2SO4. This has H plus, and note here, this has 2H plus. Okay, and we have SO4 2 minus. Okay, let's solve for the easier ions first. Okay, so that would be Ca2 plus and SO4 2 minus. Okay, let's focus on that one first. So solving for PCA. Okay, PCA. Where can we find calcium? So we can find it in calcium chloride with the molar concentration of 4 times 10 to the negative 3. So this is simply negative log 4 times 10 to the negative 3, which will be 2.40. Okay, so that's PCA. Next would be PSO4. Where can we find PSO4? Of course, in its sulfuric acid right here. So with the concentration 6 times 10 to the negative 5, which would be 4.22. So, as you can see here, this has a different given ions, right? There are no similar ions such as from the previous questions, right? But we have a slight difficulty because of the coefficients. Okay, we have these two, and with that, we need to solve this by relating its coefficient numbers. So let's start with Cl. So let's start with PCl. Since we need to focus on Cl, we can just simply put 4 times 10 to the negative 3 because there are two Cl ions in one calcium chloride, right? Not the same case for calcium, that there is one calcium in one calcium chloride, right? So that is true. We can just simply input 4 times 10 to the negative 3. For Cl, we can just input the 4 times 10 to the negative 3 because it has two chloride in one calcium chloride. Okay, let me show you that. We can solve this by putting 4 times 10 to the negative 3 calcium chloride mole. Okay, we're gonna use coefficient or stoichiometric coefficient values here. Okay, so 1 mole of CaCl2 is how many chloride? 2. So 2 mole Cl minus. And now we can cancel it, thus leaving us with the unit mole per liter chloride ion. Okay, do you get that? Why do we need to do this? Okay, because there is only one. Okay, for the case of calcium, there is only one calcium in calcium chloride. So we can just simply input 4 times 10 to the negative 3. Okay, because that's basically 1-to-1 ratio. But for chloride here, this is a 2-to-1 ratio. Okay, so let me show you. Okay, in case of calcium, we can also do this. We can put negative log 4 times 10 to the negative 3 calcium chloride mole per liter, and 1 mole of calcium chloride is 1 mole calcium plus, right? Because there is only one calcium, so there is actually no need to do this, because this is simply 1-to-1 ratio, so it's like multiplying it by 1. Okay, so for the case of chloride, this has two chloride ion in one calcium chloride, as you can see here. So it needs to be multiplied by 2. So that's why there is more step compared to this. You can just directly put it in negative log and something for its concentration. So let's solve this. This would be 8 times 10 to the negative 3, and negative log of 8 times 10 to the negative 3 is 2.096 or 2. Okay? Okay, so that's how you get the PCl. So if you want, you can solve pH yourself or you can follow along. So let's see here. pH, negative log. Okay, pH is in sulfuric acid with a concentration 6 times 10 to the negative 5 H2SO4 mole per liter. Okay, like this one, let's relate. 1 mole of H2SO4, how many mole of H plus? So there is only 2 of this, 2 of H and 1 sulfuric acid. Okay, 2 mole of H plus exists in 1 mole of sulfuric acid. So we can cancel this. We are left with the mole per liter unit. Okay, then let's solve negative log 1.2 times 10 to the negative 4. And by solving, negative log of 1.2 times 10 to the negative 4 is 3.92. Okay, so that's it. We got the PCA, PSO4, PCl, and pH with slight difference of solving from the PCl and pH because of its stoichiometric relation of its ions. Okay, so you must also be observant of their stoichiometric coefficient or stoichiometric relations because that can change how you solve its p value as well. Okay, so that would be all. Thank you for watching. And if you have any question, just comment down below. And if you have any suggestion for future videos, just comment down below. Thank you for watching and goodbye.